recording. All right, so here we go. Item number one is our calculus simile, and be ready. Well, anyway, be ready. Calculus simile. So we've seen calculus is connected to everything. And so today we're going to see what calculus is like or not like. So here we go. This is a good one, but they're all good. So calculus, taking the calculus journey is like visiting Willy Wonka's chocolate factory, not the weird Johnny Depp one, the original version. It's always an adventure, and you never know what lies around the corner. There are always treats for the good kids, but Mr. Wonka is very, very particular. And kids who develop bad habits or do things they're not supposed to do get carried away by the Oompa Loompas and are never seen again. Oh, so stay on the right path to success, and you too, like Charlie, may inherit the chocolate factory. Remember, this is an old song, so you won't remember it, but maybe you've heard it before. If not, Google it, whatever you do. Who can take a sunrise, sprinkle it with dew, cover it in chocolate, and a miracle or two? You know who it is? It's the Candy Man. The Candy Man can because he mixes it with love and makes the world taste good. So the Candy Man, look it up. It's a song. Stay on the bus. Even do, Oompa Loompas, there they are. Who wants those people to come take you away? They're scary. All right. So students, people, children, whoever you are, whatever you are you kidding me? Are you really kidding me? Seriously? I gave you 3 copies of the test, and I said, okay, now take the test. You're like, nah, I don't want to be ready for that test. I gave you these questions right here, and you came back and you're like, not really, I still don't got it. So we're going to try to get it again. It ain't going away. It's going to be on the AP test. You got to learn this stuff, folks. Here we go. Be ready to be called on. Anybody that I think is daydreaming or touching their phone or talking to someone else in their house or doing anything that has not to do with math, I'm calling on you. And oh, wait, what was that? And if I call on you, that doesn't mean that you weren't paying attention. So you don't know, am I calling you because you're not paying attention or just because I want to or whatever? So be ready. So in problem 4, and there were 2 versions of the test, and I think you guys had the red version, so I'm gonna have to remind myself, your period 4. So you were finding f of 2, and you were finding the second derivative at -2. Be ready to be called on. So I gave you in the prompt exactly what I gave you in the review. I gave you a derivative function over here, and my name, derivative function, is f prime of x. Woohoo, just like the review. I gave you an initial condition, just like the review. And this is the amount of area already accumulated, just like the review. This is the starting value, just like the review. So here's the good news. Here's the good news. The good news is I think almost all of you correctly said, all right, you take that amount of area already accumulated and you add it to starting at -1 and stopping at 2 f prime of x dx. Most of you got that. You set up the integral, you knew what was supposed to happen. So think about it, guys. Do you know what that means you missed? Finding the area of 2 triangles. You're a calculus student. Yeah, fun times. So here we go once again. The first triangle, you said, I'm going to start at -1. So -1 is here. That is a triangle, students. The area of a triangle is 1/2 the base, and the base is 1 unit long, and the height is 2 units long. Now, I discovered that some of you are having your troubles because instead of writing a 1 and a 2, you people are writing a -1 and a -2 and doing silly mess. you do the geometry to get the area of that triangle to be 1, and then you turn into a calculus student. It's like Cinderella, you turn back into a pumpkin, and you get, you know that the area is below the x-axis, so you know that that net accumulation is -1. This is so hard. Oh, wait, no, now I'm thinking about something else. And then you're going to start at 0 and stop at 2, and you see another triangle above the x-axis. The base is 2, the height is 2, 1/2 of 2 times 2 is 2, positive. So you take the -6 units of area that were already accumulated. I'm watching to see if I need to call out anybody. You subtract the area of the blue triangle and you add the area of the green triangle, and you combine like term, or you combine the integers, and you get -5. Woohoo! I don't know what to say. Okay, now let's go on to letter B, because that's the hard one that I was, oh wait, no, never mind. That's not true either. Dang it. I want some hard stuff. All right, here we go. So number 2, some of you, like I had people creating number lines and talking about second derivative test and first. I'm like, where did you go? What path did you take? Where did you turn? It literally says, find the derivative of the first derivative. Derivative is slope. It just wants the slope of f prime at -2. Dang it, stupid pen, I can't stand you sometimes. That's all it wants. Students, follow me. -2 is right here. It's sitting on a line segment right here. So if I want to find the slope at -2, I rise 1 and I run 3. Rise over run, 1/3. Now it did say set up and show your setup. Okay, well that's easy. So if this is my first point and this is my second point, then I'm going to do however you want to write it, -3 minus -2, change in y, over -4 minus -1, change in x. Now you've got a difference quotient, now you got a slope. That's what I was asking. Get your head right, get your mind right. You got to know what the symbols are asking. You got to know what they're telling you to do. You're launching off like, I don't know, I call it math vomit. Math vomit. I know, I want you to get an ugly picture. Vomit is gross. So math vomit is when you just like, I don't know what to do. I'll just go, whoa, and see what comes out. Ugh, that's gross. I don't want to look at gross stuff. I want to look at good stuff. Ask me a question. I don't want you to look silly. Ask me a question. Okay. Interpreting. We've only had about 10 assignments on interpreting, and so I get it. No, I don't. I think you're getting cocky because we've had so many assignments. Oh, I get it now. I don't need to do that unit stuff anymore. I get it now. Nope. You don't. And you know that these mistakes are costly. So you should have walked around this stuff like it was a minefield. You got, whoa, be careful. You step on the wrong thing, you're going to blow up. So here we go. Now's when I'm going to start calling names. I'm not going to call you names. I don't think I will, because that's not nice. In letter A, what are they giving us right here, Max? Just read what I circled.
R prime.
That's right. So they're giving me R prime. All right, next question. What does R prime, and I just want the name of the function. What does R prime modify, Chantome? Just the name of the function.
The derivative of R?
No, R prime is the derivative of R. So what does R prime modify? What does it describe or tell me about?
The preceding function?
Well, Yes, 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 yes. So what function precedes R prime?
R.
Yes. So R prime modifies R. According to the prompt, you can't make this stuff up. According to the prompt, what is R, red R, what is red R a measurement of, Zachary?
Water leaking from the pool.
No, it's not. Why are you lying?
The rate of the water leaking from the pool.
Camera's laughing at you. Rate water leaks from the pool. Okay. What function did they give me, Afia? Oh, you're having, it's okay. It's okay. You told me you're having some internet issues. What function did they give me, Emily? In the
In the prompt or in the question?
right here,
Oh, okay. R prime.
they gave me R prime. What does R prime modify, Alejandra?
Preceding function,
And what is the preceding function, Alejandra?
R.
R. And Eric, what does R represent in this problem?
The rate that water leaks from the pool.
Perfecto. So when I start writing, what is the subject of my sentence, Shirley? What's the subject of my sentence that I'm going to write?
The water leaking from the pool.
Nope. Oh, I heard myself. In the box.
Rate of the water leaking from the pool.
Okay, so we're going to do this again because Chantone told us, and he got all these right if I remember correctly. He said R prime modifies the preceding function. And then we said R is the rate water is leaking from the pool. So Taiki, what's the subject of this sentence again?
The rate water leaks from the pool.
What's the subject of the sentence, Shoshana?
The rate of the water leaking from the pool.
So what we're going to say here, students, is at 10 hours, here it comes, the rate water leaks from the pool is decreasing at a rate of 0.758. Now I'm going to stop. Stupid pen, I hate you. 0.758. What are the units? Stay with me. What are the units of R? Haley, what are the units of R according to the prompt?
Cubic feet per hour.
Perfecto. Cubic feet per hour. Now, if R, red R, is measured in cubic feet per hour, what are the units of R prime, Cameron?
Feet cubed per hour squared.
Correct. Cubic feet per hour, stupid pen, squared. So when we write at a rate of 0.758, we're going to say cubic feet per hour squared because R prime is negative. Don't look silly. Ask me a question. Okay. Going to letter B. In letter B, what does P, it's in the prompt, guys. Don't be scared. Nobody should be scared. Well, nobody should be scared, period. But what does P, according to the prompt, what does P represent, Claire? The function P.
The rate of water being pumped into the pool.
And I'm just going to write for shortness in rate. What are the units of P? Talia, the units of P.
Cubic feet per hour.
Okay. When you integrate a rate, what happens, Colette? When you integrate a rate, what happens?
You lose the rate.
Correct. So we are accumulating cubic feet. So this was, and most of you got this right, if not everybody, this was the accumulation of the amount of water being pumped into the pool. But there's an actor who talks like that. I can't remember who it is. It measured in cubic feet from 0 to 12. Ask me a question. I know, but it looked like I was frozen, didn't it? That was funny. All right, to me. Letter C. A lot of us went off the rails again, just totally went off the rails. Okay, here's the good news. I always like to try to bring you some good news. Be ready because I'm calling on you, but not a sheep. So 1/12. Most of you by now, like when I see that, I know it's averaging. Some of you didn't get that joke. So this is going to be an average. The problem is you didn't know what it was an average of. You told me the wrong thing. You told me it was the average of the amount of water. Not at all. It's the average of what function? Irene, what function? I just gave you the arrow. What are we averaging here?
R.
Okay, so we're finding the average of R of T. According to the prompt, what is R of T? Brian, what is R of T?
Rate.
Is it the in rate or the out rate?
Average.
It is the out rate. What units are R of T measured in? Alejandra?
Feet.
In the prompt. Here, let me slide the prompt up.
Oh, RT? Is that
Yeah,
what
R
you
of
said?
T.
Oh, cubic feet per hour.
Okay, so students, this is the average value of the rate at which water leaks from the pool measured in cubic feet per hour from 0 to 12 hours. It's not the amount. Doesn't make sense to be the amount. We accumulated the amount here. Now you're dividing it by time. If you take the amount divided by time, you got a rate. When you divide, you got a rate. Questions? Okay, you're next. Be ready. Whoa, so A and D are the same concept, and most of you, honestly, most of you got A, and a whole lot of you who got A fell totally apart in D. And I told you and 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 told you. College Board is not looking for you to give a translation. Listen. A translation is simply when you tell me what I already told you. So those of you who said this, listen, think about it. Was it you? At 3 hours, the rate at which water goes into the pool is 49 cubic feet per hour. I already told you that. I already told you that in the prompt. I told you what P was. I didn't ask you to translate at all. I asked you to interpret. Interpret. All right, now from the prompt, we already know that P is a rate. Shantone, I'm going to go back to you. What does a rate always do, Shantone?
It precedes the function.
Well, no, a rate does what to the preceding function?
Derivative?
No, you're doing math vomit, Shantone. You're trying to say math. You're not listening to me yet. What does a rate do to the preceding function? What does it tell you about it? Like based on this number right here, what are you going to tell me about the preceding function, whether it does what or what?
I'm not sure.
It's okay to say I'm not sure. Max, what does a rate do to its preceding function?
Whether or not it's increasing or decreasing.
Yeah. Or, a lot of you have heard me keep talking about modify, which is the same thing. Increase, decrease is a modification. It tells you what's happening, okay? So a rate modifies its preceding function. What does a rate do, Shoshana?
Modifies a preceding function.
Okay, so in this case, P is a rate. What units, and I'll bring it back down in case you can't remember, what units are P measured in? Emily, what units are P measured in?
Cubic feet per hour.
Cubic feet per hour. So the rate is measured in cubic feet per hour. If the rate is cubic feet per hour, what are the units of the preceding function, Eric?
Just cubic feet.
Just cubic feet is right. So the preceding function is cubic feet. In this problem, what's measured in cubic feet, Cameron? What's measured in cubic feet in this problem? What
Like
was
the
it all
water?
about?
The
The water
water?
in the swimming pool. Yeah, so amount of water pumped into the pool. So the interpretation is this: at 3 hours, the amount of water pumped into the pool is increasing at a rate of 49 cubic feet per hour. Ask me a question, because you're going to get more, I'm telling you right now, after spring break, you're going to get more graded assignments on interpreting, and you can either keep getting hundreds or you can keep getting me, because the more we do this, the less partial credit I'm giving. It's going to be an on or an off. Because at some point you got to get this into your brain, or ask me a question and stop looking silly. Anybody got any questions? Okay, I will check your uploads here shortly. Allegedly, you watched a video of volume and saw that it's a continuation of a concept that we've already talked about. The difference here is that instead of revolving, we are making other shapes. So that's really the big deal. So on page 24, I walked you through what some of these look like, and I talked about making a cake, and I talked about the plate of the cake. I talked about how to accumulate. I talked about the connection between geometry and calculus. I gave you another example. I gave you all kinds of views of what these fancy schmancy cakes look like. I told you how we are accumulating. And so on page 25, if you forget, it says, hey, if you need to find volume by slicing, there are 5 steps, just like your AP score, 5 steps that you follow. Then I gave you some examples that you copied down, and then allegedly you did a homework, then allegedly you checked it with my answers, and then allegedly you went to my video to get support on the things that you were not sure about. And that's what I'll be checking in the upload that you did today. If you didn't upload, stay on the Zoom at the end. All right, so let's talk about what you're going to do. Let's talk about the homework questions. So here is your task to take care of. Due by Sunday, you're going to practice more of these problems, and we're going to get a couple of them knocked out before we end our session today. You're doing 1D, 3D, 4 to 7. So why don't you go ahead and go to page 26, put a box or a circle or a triangle or a star or whatever you want to do around the problems that we're doing so that you already know and you don't get lost or confused, but don't start them now. We'll start them in just a minute. The upload for this assignment opens today at 3 o'clock because so last in period 3, somebody said, Mr. Jernigan, you're going over, we're doing these in class today. I've already done them. I've already checked them. I've already watched your video. Can I go? I'm like, yeah, of course you can go. He said, when did the upload open? 3 o'clock today and closes midnight Sunday night or 11:59. There is video support and the links are on the assignment sheet for all solutions, the posted solutions as well as a video. So here was my compromise for the 70-30 break for spring break. 70% of kids said, let's go it, let's do it. I want to be ready. I want to learn this stuff. So here's what I decided to do. I kind of met it somewhere in the middle. So here's your job. Here's your task. And my strong recommendation is that you not do this until towards the end of spring break so that it's in your brain when we come back. You will need your slope field packet. You're going to watch my YouTube video, which is linked on the assignment sheet. Click and go. You're going to stop the video at the 25:40 mark. That doesn't mean that you're only going to spend 25, 40 minutes and 40 seconds. No. Your notes and the video notes diverge at the 25, 40 mark, and I don't want you to keep running the video. I want you to focus on your packet. Take the notes in your packet, even though they look a little bit different. It's the same examples. You'll be able to follow it. And when the guy in the video, it's me, says stop and do this, stop and do it. And then we'll finish the rest of the packet after the break. So that's my compromise for the 70-30 split vote. Well, it's not split, but leans heavily on getting the work done. Anybody have a question at this point? All right, any questions for the homework that you've done already on volume by slicing? And it's the yellow highlighted problems. Anything that my video did not support, the answers didn't support, or just a general question about volume by slicing. Oh, if you're putting your hand up, I hope y'all have been raising your hand. I took away my participants bar. William, go ahead.
Can you do number letter D?
Well, that's today's assignment.
Oh, that's it. Okay.
I mean, we're going to work on it in a minute, but I'm just talking about what you already have been assigned. Abby, go ahead.
Can you go over part 3B?
3B, that's interesting. That was a question that was asked in period 3. 3B, whoops. All right, so tell me when you get to 3B, Abby. Oh, my work's still there. So here's the deal with an isosceles triangle. And that's really, I think, where students were like, I sort of get this, but this isosceles triangle makes me a little bit nervous. So even though I have the work over here, Abby, I'll kind of refresh it again. So whenever you have the isosceles triangle, students, everybody pay attention. I'm going to call your name out if you don't. The first thing you should do is, Abby and everybody, draw an isosceles triangle so your brain gets wrapped around what an isosceles triangle is. That's really important because in an isosceles triangle, the base and the height are equal to each other. So even though the area of a triangle is 1/2 base times height, since the base and the height are equal to each other, that's really the same thing as 1/2 base squared for the area of an isosceles triangle. Now it says that a leg is in the base of the region. The base and the height, they are my legs. So when I do the slice all the way across, this blue segment corresponds to this blue segment right here. So in order to get my formula, I need to know the length of that base. I'm just watching y'all right now. And so I'm going to take the top of the segment, just like I've been doing all along before, minus the bottom of the segment, just like I've been doing all along before. So it's going to be the top curve, 2 minus x squared, minus the bottom curve, minus x squared. So the length of that blue base is 2 minus x squared. And since my formula for the area of the triangle in this problem is 1/2 the base squared, I'm going to bring the 1/2 out front as a coefficient. I'm going to accumulate from -1 to 1 because we are in terms of x. And then I'm going to take the base and substitute it in here. And I'm going to square that and go on about business. So Abby, did I hit what you needed?
Yeah, thank you.
Okay, so students, here's our deal. We're going to do together, we're in class, we're going to do 1D, and then we're going to do one problem in terms of Y, and then we're going to call it a day. So everybody get your paper out, go to problem 1D, whoops, and get that set up. I'm going to mute myself for a few minutes. I'm going to give you a head start. You're not here to copy my work. You're here to do your work and get confirmation. Anybody have a question before I mute? ask me questions. Max?
Oh, could you go over how you got that B value?
So you can see on my screen that this base right here, I'll color it again, corresponds to this base right here. You're okay with that, Max, right?
Yeah.
And for a lot of these problems, you're going to be using the beauty of symmetry. So what I did, Max, and everybody, because it's the same question everybody has, is it's easy to go from this curve to the x-axis. And I know that the segment, because the circle is symmetrical, that the red segment is congruent to the black segment. You with me, Max?
Mm-hmm.
So what I did is I said, all right, then I'm going to go to the top of the circle, which is the positive square root of 1 minus x squared. Let this be the bottom, minus 0. And since these segments are congruent, I'm going to double that length. That's really the same thing as touching the top of the circle, which is 1 minus x squared, negative the bottom of the circle, because the bottom of the circle is the negative part of the equation. And if I do zip zap, square root of 1 minus x squared.
Oh, okay, that makes sense.
That makes sense. And that's going to happen a lot. And I'm hoping that you guys kind of did that when you were doing 1A and 1B. Other questions? Other questions? I don't see any hands. I don't see anybody coming off onto mic. Everybody knows where the 2 came from, the 3 came from, the bounds came from. And this is clear, definitely a calculator problem. You don't know how to integrate that function. So if you integrated it, you're in trouble. You don't know how. Definitely, Zach, I can tell you did. It's a calculator problem. All right, let's go to our last problem before spring break. We're going to look at number 5 because number 5 is a very, very dangerous problem. Semicircles are extremely dangerous. Sketch it, set it up, write the formula, do all the intermediate steps. I'm going on mute. Ask me questions. Semicircles are really, really dangerous, and they're dangerous because of the radius versus the diameter. I tried to color and highlight and show and tell and fix, but it might not be clear to you. Don't look silly. How did you know? What happened to where did that come from? Those are your sentence starters. Emily, go ahead.
I wanted to, how did you get the pi over 8 in front of
So the pi over 2 is coming from the formula right here. So there's the pi over 2, okay? The over 4, when I squared my radius, I have to square that denominator, and that's a 1/4. So instead of putting it into the integrand, I'm getting it out front, out of my way, so I don't have to deal with fractions. And then the 2 minus y is what's left over. That's my r squared. It's already been squared, so I don't square it again. And so that's where that came from.
Okay, thank you.
Yep. Next question. Next question. I know you know how to copy. I'm looking for people who are like, I just need to understand what happened, why, how.
Mr. Jernigan, I have a question. Like, I just get confused. Like, how do you relate the graph to the shape? Like, how do you know where to draw and relate the radius?
I'm not sure I understand that yet, William. How do you relate the shape?
Like when you start a problem, I get how you graph 2 minus x squared. I get that one.
Mm-hmm.
The shape that we're gonna relate that is a semicircle. So then, based on there, how do you know where to graph it or
So the only thing that you're going to see, you're not going to see those fancy shapes that I showed you earlier in the early part of the video. All you're going to see right here is a slice. All you're putting in, that's why I do all this extra stuff. So the slice is right here. That's the slice. And then I draw a semicircle down here. Like if I could see this 3-dimensionally, but I can't, and I can't draw it 3-dimensionally, I would see a series of semicircles. So you'll notice if you use my video, you'll notice that I always make that segment, and then I color this segment to show you what part of the semicircle is sitting on that plate. The bottom of the semicircle sits on the plate. So this purple segment is this purple segment. We just don't see the semicircular part.
Okay.
It helps or not. But the videos, I think I do that in all the examples to kind of show you. And even if you look at my solutions, these are some really nice solutions. It shows you the shape, it shows you the slice, it shows you, I can't get the page, there it goes. So notice in every time I showed you the geometry shape, I showed you the slice, I showed you the step-by-step. And students, if you're going to get these right, you have to do this very step-by-step. You have to think about geometry. You have to think about the side. You have to think about the slice. You have to think about where you're perpendicular to. There's lots of stuff involved here. It's not that hard, but there's a lot of stuff involved. All right, students, your task is before Sunday. Don't be so excited. Your task is before Sunday 11 or by 11:59. Get this work done, get it uploaded, and then you take a break, refresh, get rested, recharge. Then you come back, you get the slope fields knocked out, and then we'll clean it up, and then we're going to start cranking on review. So get your review materials, your 2 packets of review materials, your what do you call it? Reference material, resource, or I think I call it reference material, whatever. Start looking at what you've got, and we're going to start doing some review. So anybody got anything for me? All right, if you have questions, stay on. If you talk to me, stay on. Otherwise, have a great break.
Thank you. Thank you.
Thank you.
Hi, Steven, what's up?
I posted something right in the chat, like for 5C of the test.
Let me read it. Let me read what you wrote. Jernigan, the area test, I said 1/12 from 0 to 12 represents the average value of the water. It's not the average value of the water. It's the average value of the rate water is leaking out of the pool. It's the average value of the rate.
The rates. I see.
Okay.
Okay, thank you so much. Yep, I missed the rates, the word rates. Thank you.
Okay.
Have a
Great
great break.
Stephen. Bye-bye.
Bye bye.